is 3 because there could be a case where I'm breaking the number into 3 plus something else. Right?
Base of 3 is 2, right?
Yeah.
I think if you
So
put it
here there is a
yeah,
gap
and
between
it's for
integer
it.
break and breaks. No, what I did is correct.
It's because in the recursion we wrote it as I into j into I minus j.
Yep.
But here we are using breaks of
Oh,
j
shit.
into I minus j. That's why I think we need these base cases, is it?
Yeah. Yeah.
If it is just j into something, then it shouldn't be a problem.
Yeah, let's test that.
We'll try this.
Yeah, let's test that. Actually, that's going to be wrong because that's like saying that I have to break it into parts where one of the numbers is j. Like that's a wrong imposition, right?
Yeah, that's how, but that's
So if I
that's
just
how
do
we are
j
taking
times
the
I minus j,
That's how we are taking the max, right?
yeah, but there has to be one such part, right? Okay, let's try this.
But yeah, why are you considering
Yeah.
takes of 3 is 3 where it's break of 3 is 2?
But I think still we will need all the three bases.
Yeah.
Because what if 2, 3 comes in the second quotient? So what if I minus j becomes 2 or 3, then we need that value, right?
I minus j becomes 2 or 3, yeah, then we need these.
Do we need that?
Yeah.
Just wondering.
Yeah, we need to need that because if you don't have 3, then you're not breaking it into parts where one of the parts is 3. That's in it. So you will be excluding all those cases where in my max product, one of the numbers is 3. Because none of these is 3 yet.
So
this
base
is-
of
That's kind
3
So
is
if I don't have this, it will definitely break case. Of that, I'm like
I'm just
100%.
trying to find out the reason why it breaks.
Yeah, why it breaks is if I have to
So
have a
the
number where
solution for 3 is not the
Yeah.
best. That's what we say. I mean, best for others. The solution.
okay, hang
for
on. So I'm not sure if with this you need breaks of 3.
I'm just wondering.
Yeah, let's run this and see. This could work. Yeah.
We need to remove it, right? We
Yeah,
need to
and
remove
yeah,
it.
and here I could do this, and it might still work. Okay, then I need to do 3. My bad.
Ah.
Yeah.
Do we need the other two? I mean, break of 1 is
Base.
1. Do we need do we need any initialization in that?
You guys tell me.
and equals to 2 you will do
We need to start with 2.
2.
Oh, right. Yeah. Ah. Yeah.
No.
For n equals 4. So for n equals 4. Yeah, you would have 2 on breaks of 2, right?
Yeah.
Yeah, actually 3 into breaks of 1 also, right? And
No. So for n equals 4,
okay.
I'm gonna have 2 times breaks
That's
of 4.
what the I minus j when it becomes 2 or 3.
Yeah, and at that time breaks of 2 would be what? There'll be a breaks of 2, but it won't be 2.
Base of 2 is just 1, right?
Yeah, it'll be 1.
Yeah.
It'll be 1, so that's why.
Yeah, that is so tricky.
Yeah.
It's not
So-
in a proper recursion.
Yeah, it's not a proper recursion. That's why I'm handling special cases for n separately, but in my array I have different values. Yeah, but this is very interesting. I'm glad we ran into this. So I think if I just do 2, it'll work. Okay, now for breaks of 3, I think it will do 2 times 1. Yeah, and again, even here breaks of 3 will only be 2. Yeah, breaks of 3 will only be 2.
Kind of tricky. For 4, you get a better answer, right?
Yeah, for 4, you get 4 because 2 times 2. From then onwards, I think you get that value for.
For 5 we get 4.
For 5, you get even something better, 6.
6,
Yeah.
Hmm.
So,
Strange.
yeah. Yeah, this problem is deeper than I thought. Oh yeah, so yeah, it'll only work for this. It won't work for even if I comment out this line.
When this problem comes, we should remember the fact that if the answer is lesser than that particular number, then we need to initialize.
Or you could just start approaching this as a new problem and you'll eventually figure it all out.
When like 40 minutes, how do you come up with those basics? Like you know the logic, but you are just stuck up with some kind of basics.
Yeah, that happens all the time.
Yeah, I think it'll still help to like have a clear head and approach this problem freshly. You can come up with this like a, yeah.
But we won't know these test cases in interview. That is one major problem. We will write our own test cases and okay, it's working.
Yeah, another good thing is in an interview, they won't run it on an OJ. It's the interviewer running it, so he may not be that careful. You could get lucky. So if he sees something wrong, he'll tell you what it is that is wrong. Right? Okay, but this is like DP, right? You build up like bottom up, and then you get an answer finally, right? Okay, is there some other comments you guys want to make about this, or? Okay, let's move on. Okay, this is very interesting. Like whenever BST comes, I find that super interesting. Okay.
One thing that strikes my mind is
Yeah.
if there are n, the height of the tree could be n. That is the best solution.
Yeah.
And the best solution is log n. So
Yeah.
it should be a number, we should do something in between and try to
No, this is the total number of trees that are possible. You're talking about the height.
height, yeah. I mean, in between them, the combination, that is the answer, right?
It's not between them, it will be the sum of all those numbers.
Okay, sum of all those possible.
All those possible trees. How many trees are possible? Okay, does everybody get this question? So basically you need to build as many binary trees as you can with the number, binary search trees as you can with the numbers from 1 to n. Right? So you're supposed to calculate how many trees you can build. Right? Okay, so how do you want to do this? Okay, so this class is DP. So if you know a problem is DP, the first thing, what should you ask yourself?
How do you break it?
Recursion. Yeah, basically that. So how do I build this from a smaller version of the problem?
Since the BST, my question is,
Yeah.
are the keys sorted?
Yeah, it's a BST.
No, are the keys which are given to me, are
I
they
mean,
sorted?
we are just given the.
You're just given n. You're just given n.
I mean, what we can do is start off with first as a root.
Yeah. What do you mean first as a
Like first key, whatever first
it's
value.
The
one
keys are 1 to n. The keys are 1 to n. 1, 2, 3, so on up to n.
Okay, I'll take the first as a root and consider.
What is first as the
I
root?
mean, one as a
Okay, yeah, good.
yeah,
Yeah.
one as a root and consider a tree.
Yeah.
And then since it's BST, the subroot behind a subtree.
Yeah.
So then it should be then take second as a root and then see what is structure. Then change one again to two and do the same thing again.
Why would you?
So you take this first time you take one as a root.
Yeah.
Next time you take two as a root.
Yeah, exactly. Yeah.
That's what.
So basically, of all the subtrees, of all the trees that you can make, what are the possible roots?
All the
All the values from 1 to n, right? So I individually calculate how many trees I can make with 1 as the root, 2 as the root, 3 as the root, so on. Okay? Now let's say n is 10 and I chose to pick 6 as the root. Okay? Now how do I calculate how many trees I can make with 6 as the root?
The other positions will be like minus that, I mean, the values, each position will have a possibility. Now if we are freezing 1 as the root, then rest of the 9 members.
Yeah, that's why I don't think of 1 as the root. Let's do 6 as the root.
Then the 5 numbers that are on the left side,
Yeah.
they can be at all the
It's
places.
just five or
Yeah.
subtrees.
Yes,
Say that
yeah,
again.
so the
If we take 6 as the root,
Yeah.
and then the number of subtrees for 6,
For
and
six,
like,
yes.
for that would be the number of trees for like 6.
For 1 to 5 and
Because of
7 to 10.
Yeah. So basically, if I take 6 as the root, what are the trees that I can have on the left?
Less than 6 in it.
All trees that I can have from 1 to 5, right? So let's say there are 10 trees from 1 to 5. Each of those trees can be the left tree of the 6 being the root, right? And what are all the trees that I have on the right?
Greater than 6.
7 to 10, right? All trees that I can make with the values 7, 8, 9, 10, right?
And that's the main tree, whatever. The current
What is
tree.
plus?
And the current tree, which was you're calculating with 6 as a root.
Yeah, that's what I'm calculating. So right now I'm calculating how many binary search trees I can make with just 6 as the root, right? So on the left, all my candidates are trees that I can make with 1 to 5. All BSTs that I can make with 1 to 5. And on the right are all the trees, all the BSTs that I can make with the values 7, 8, 9, 10, right? Yeah. So do I need to know what those trees are, or what do I need to do to compute the total number of trees?
Number of trees we know that for.
Yeah, so what number of trees of what?
In that given way for those trees.
Yeah, for 6, like what do I need to do? Okay, so right now I have to make the calculation for 6, right? So so if you're like kind of struggling to come up with the recursion, just write the recursion for like some specific values, and maybe they'll help you see how to write the recursion for generic I or n, right? Okay, so for 6, how do I calculate? Okay, hang on. It's not f of 6. So f of 6 is where I'm only looking at trees from 1 to 6, but I'm trying to calculate all the trees that go from 1 to 10.
With the given root.
And in this, yeah, if 6 is the root, then how many trees can I have? It's just 6 as the root.
F of 1 to 5 plus f of 6, 7 to 10.
Yeah, what is f of 1 to 5?
1 as a root, 2 as a root.
Oh, f of 6, f of 5 plus
Which is what?
f of 5 plus.
Yeah, exactly. It's f of 5, right?
Oh. Ah, yes.
So basically, if I have 6, then as the root, then my left subtree will have like 1 to 5. And this will have 7 to 10, right? Okay, let's say I know these numbers. Then what is the number of trees that I can get for 6 as the root?
Oh, it is F.
Left
So
plus.
1 to 5 plus
F minus
Sum of 1 to 5 plus. Okay, you tell me.
F of M minus
No, hang on. Did you guys get my question? Let's say this is n, okay?
F of 5 plus.
No, there is no f now. So my question is, the number of trees you can make with 1 to 5 is n. The number of trees you can make with 7 to 10 is n. So what are the total number of trees that are
N
with
plus
6?
M.
Really?
N plus n plus 1.
Oh god. Come on.
N into n.
Into m, because for every single one of these trees,
You
I
get
can have
Oh.
each m as the right subtree, right? So it's n times n. Okay? Now the real question is, what is n and what is f?
N is
F of 5 into.
Yes, awesome. Okay, it's not this f. It's this f. So we're calculating this. Let me call this f1. Okay, f of n is sigma f1 of I, where I goes from
0 to n. 1 to n.
1 to n. Yeah, right? And yeah, you guys see the difference, right? F1 and f, there's a difference.
When we have that element as a root.
Yeah, f is, I want to know all the trees that I can form, all the BSTs that I can form with the values 1 to m. Okay, it's actually f of 10, it's not f of 1 to 10, it's just, so there's nothing, this is f of 10. So f of 10 is nothing but f1 of 1 plus f1 of 2, because f1 is all the trees, f1 of I is all the trees that I can have
with that root.
that's rooted at I, but all the values in that tree are 1 to m or n. Okay, so there's two things. There is n and I, right? So f1 is all the trees that I can have with I as the root, but the nodes itself are from 1 to n, or have values from 1 to n. Okay? So now, what is n and m? Okay, I don't want to use n again. So let's do like k and l. Okay, now again back to the specific problem for 6. What is k? What is all the trees that I can make from 1 to 5? With f1, like use this terminology until the answer.
S of 5 into
F of? Okay, so this is f of 5. Right? Is everybody seeing that? So basically I need to know all trees that I can make with the values 1 to 5. Right? So that's what f of 5, because that's the problem I'm trying to solve. All trees that I can make from 1 to n. Right? So this is f of 5. So f1 of 6 equals f of 5 times L. What is L?
That is also f of 5, right? 5 elements.
Are there 5 elements?
Sorry. 4 elements.
Awesome. So what is it?
F of 4.
Awesome. So even though it has the values 7, 8, 9, 10, I would have exactly the same number of trees as 1 to 4, because 7 is 1, 8 is 2,
My question is
9 is
not-
3, 10 is 4.
So when you're doing this, like taking each key should be input sorted, it doesn't matter.
No, I'm only taking consecutive numbers. There's no
Yeah.
sorting. They're all. It's a BST, right?
So when you can construct a BST with any, like the array can be any form.
Yeah, that can be any form.
Yeah, so it depends like what the length of your tree when you're given, but
Yeah.
if it's not sorted then you will have a different
Right,
level.
right.
We
I don't
don't,
see
I mean,
how
it's
sorting is
jumbled, it's not one sorting order, it will be all combinations of.
So but when you are
that array.
setting it up, how does this happen? Is my like I'm getting
So if you
I
have
don't understand
7, 8, 9, 10, it can be 10, 9, 8, all
Yeah.
possible combinations of 7 to 10.
Okay. So to address Sesha's question, I'll open another window and let's draw all. Okay, basically I don't need to, because so this is all BSTs that I can form with the values 1 to 3. So what is your question about sorting?
So now take the case of 2 where 2 is the root and you have left 1 and right to each.
Yeah.
So this is done usually like is drawn it, but if you're given an array like
Yeah.
some random like
Yeah.
3
You're not given an array, by the way. You're only given n.
n.
Yeah. And you're supposed to calculate how many BSTs you can make with the values 1 to n.
Yeah.
Where the nodes have the values 1 to n. Yeah. So where is sorting coming in?
When you are dividing that, like you're splitting the keys, right? So basically you're taking
Yeah.
each element as a root
Yes.
and you want to make a product of the left subtree and right, what is the
Yeah.
right subtree? In the right subtree,
Yeah.
like why are you assuming that like you have all the elements there? No, so that's the property of BSC, I get that.
Yeah.
But then I still don't see like how do you get like the element right, like already to the right like that. That's why I'm getting confused.
No, I still don't get your question. Did anybody else get his question?
So, if you have something wrongly, for example, with this 2, 1, 3,
Yeah.
if you are going to have 3 on the left, it's not a BST. So, we
Yeah.
are not going to count.
Yeah, I know
it.
when you're making a product, we are taking the property of a BST that all the left to the
Yeah,
or the root are
because we
smaller
need to
and to the
find
right.
the number of BSTs.
Okay. Assume the question. I thought something else.
Yeah. Maybe you're getting
I'm mixing
mixing
up
up things.
something
Yeah. So in a BST, if you do an in-order traversal, you get the sorted order. That's it. So I would get 1, 2, 3 if I did in order for all these trees. Right? Yeah. So that's it. So this is your recursion, and f1 of I. What is f1 of I? It's not sigma. Sorry, it's not even sigma.
F of
Yeah, exactly. F of
I minus
yeah. F of I minus 1, because all of my left subtrees will be all the trees that I can make from 1 to I minus 1, right?
into F of I minus 2. I'm just thinking.
Yeah, it's not f minus.
I.
Yes, awesome. So it will be whatever values I can make from I plus 1 to n, right?
Yeah.
And how many values do I have from I plus 1 to n? N minus I plus 1 plus 1, so n minus I,
And one.
right? Yeah. Ah. So if you put these two together, it's basically like two for loops. I have one sigma here, and no, it's only one for loop. Oh,
Of n
okay,
will be
okay,
one for
okay,
loop.
yeah. So I need one for loop. Hang on. I'm just wondering if this is O of n or O of n squared.
It's definitely n squared stream, but I'm not.
Yeah, it seems like O of n because I have one summation from 1 to n, and each of these things,
Is a product again.
yeah. Okay, let's code it up. Right? Yeah.
So,
Yeah.
how do we get to the base cases? We need to initialize some value, right?
Yeah, good question. Yeah. So let's talk about base cases. Yeah. So yeah, in DP, like in recursion, you come up with the recursion itself, and you need to come up with the base cases. Especially if you're building like from bottom up, and that bottom has to start somewhere, right? Yeah. Okay. So here in this problem, there's like a super intuitive and nice base case. So what is f of 0?
Assume there are no keys,
Yeah, f of 0.
0.
No?
So no keys.
No keys.
Yeah.
Empty tree.
No. It's the null tree, so it's a 1.
Oh,
Because that node itself is null. Yeah, and why we do it that way, it's basically what you want it to be, like it's ambiguous.
Yeah, it's assumption what we make. If you are given just a one key, that's also one node, one tree.
Yeah,
You're
yeah.
right.
If you're given one node, then it's definitely one tree. There's no ambiguity there,
Yeah.
right? But for 0, it makes sense to assume 1 because let's say I'm calculating f of 10, and I want to calculate f1 of 1, right? So how many trees do I have for the left guy?
0.
No, we have one tree for the left guy, which is null.
Okay, because we multiply, so it has to be 1. If it is
Yeah, we
0,
multiply,
then
and the left guy is like for any tree there is no undefined node. That a node, if it doesn't exist, that means that node is null, and that is one tree, right? And it works with our calculation because the left guy will be 1, and in multiplication I'll be just multiplying 1 with whatever trees I can make on the right side, which will be just that, right? Yeah. So. Okay. Okay. Tell me what do I type first?
Yes.
Sorry?
Create an array basically.
Yeah.
Solution.
Of what size?
N.
N?
N plus 1.
N plus 1. Why n plus 1?
So we have null tree is 0.
Yeah, so whenever you're creating these data structures, it's really helpful to have at what index, what am I representing? It's very important to have that notion clearly. So here at index I, what do I store?
the
Number of trees
answer
for that.
I.
Yeah, exactly. So here, num trees of I is nothing but num trees, this function of I. Yeah, so if you want to get n, then you need index n, which means n plus 1, right? Yeah, so, okay, tell me what else?
Yes, yes.
I can't see you guys if I'm sitting and typing. Okay, well, so what's the base case?
0.
Okay, next.
And so
Yeah, okay, so it's with coding, like you can always go back and change. Right now it's not very clear if I need to write that base case too, right? So, okay, so tell me what else?
now you
For
Yeah. Yeah.
n
And-
equals to
First
1
for each one.
to n.
1, 2.
Okay. Yeah.
Now,
Do the
trees
calculation.
of n equal something.
Num trees of n equals to something.
Another function basically f1 that is
No, plus equal, right? Sorry.
num trees of n equals-
Num trees of n.
I.
I. Yeah.
Yeah.
That's my question. Okay. Yeah.
Again, we,
Function of I into n minus I.
Yeah. That's where the recursion comes in.
Yeah.
So this is my recursion, right?
So it's in square solution. We have one more problem.
Wait, where is the other for loop? So f1 of I. So this sigma is this for loop, right?
yeah. The sigma is first
Yeah.
for loop.
Yeah. One second. Let me just readjust this. Yeah. So this. Please. Okay. Yeah. So this is f1 of I, right? Oh, right. Now it makes sense. Now, yeah. So the thing is,
I think we cannot.
yeah, it's two for loops
Yeah.
because
Yeah.
this f of n, I conveniently assume that I have f1 of 1 to n, but
We need to.
you need to because you also need to calculate f.
Each
This
for
depends on the
I.
past f's,
Yeah.
the f's of 1 to n minus 1.
But we need
So I need to
store
calculate
this.
that as well, right? So do you guys get why we need two for loops? Okay. Okay, so let's start off by writing simply, right? So that will be num trees of,
I minus 1 into.
yeah, so okay, so I'm calculating num trees of I. So num trees of I could have roots from 0 to I minus 1,
Yeah.
right? And it'll be the sum of all trees that I can form with root 1, root 2, root 3, so on up to I, right?
So, yes.
So basically this should be like, let's just say
Yeah. So.
num trees. Let me just call this variable num trees. So this will be some num trees that I need to calculate above this. Okay, J. What is the range for J? So J is basically the root now. So for J equals 1, I'll be calculating how many trees I have with root 1.
Less than I.
Minus 1.
I minus 1.
So for each I, I'm going to calculate the number of trees from 1 to I. Right?
Yeah.
So in all the trees from 1 to I, what are the possible root values?
0 to I minus 1.
No, root values. 1 to, why I minus 1? Why can't I be the root?
I can do one.
Yeah, so 1 to I. Yeah, that's everybody said 1 to I minus 1. Does this make sense? Okay. Okay, what is this now?
That's f of
So
n
with,
minus-
yeah, so now I know like inside here, I'm trying to calculate all the trees from 1 to I, and for each j, j is the root. So right now j is the root. So how many trees can I have with j as the root?
One. Yeah.
Yeah.
Trees of j minus 1.
Good.
That's n minus j.
Plus,
Yeah. No, into, sorry.
that's it? Okay, so, and then what do you return finally?
Trees of n.
Yeah. Okay, now it's, so whenever you write code, it's best to like, in your mind, run it for a base case. So let's just run it for 1 first. See if it at least works for 1. So n is 1. So this is okay, this will run.
I think you should set the numbers to 1, right? Or to 0.
1.
The value of numbers equals to.
Oh, here? No, it will be 0 because I start with 0 and then I add.
Adding it. Okay.
Yeah. So now I start with n equals 1. So I equals 1. So I go in. And this will also go in. So now I have 1 minus 1, which is 0, which is 1. And 1 minus 1, which is 0, which is 1. So this guy becomes 1. And with 1 as the root, I only have 1. So it definitely works for 1. And yeah. Yeah, it seems like it will work for other integer values, right? So for n equals 6, I have I equals 1, I equals 2. For I equals 3, we go from j equals 1 to 3. And for n equals 3,
Like, my dot and numbers were already initialized. Why are we taking numbers 2 times? In
Which lines?
Is an array, then again.
Can you change the variable name because it's confusing? It's
yeah, the
not
function
real.
name is the same as the variable name.
I mean,
Yeah, you can do that. You can do that.
Initialize, yeah.
It's F1, right?
Yeah. So this will be, yeah, like come up with a good name. Like you guys did PDP recently than I did, so. Oh, some of you did not do PDP, right? Yeah. Okay. Those that did.
Number of subtrays in root I and root I.
Anta pedda peru.
Numbers sub.
Sub? No, I don't like that. So, this is your num tree. No, it's not number of subtrees, by the way. So this num tree is basically calculating all the trees from 1 to I. All the trees that you can make from 1 to I. It's not number of subtrees. So yeah, just this. What? Okay, so while it's running, so let's say n is 6 now. Okay, let's just run this inner for loop for just j equals 3. Okay, for j equals 3, what values do I have on the left? 1 and 2. So that's num trees of 2, right?
Yeah.
So if j is 3, I have num trees of 2. And what values do I have on the right?
4, 5, 6.
4, 5, 6, which is num trees of?
6 minus.
You calculate till 3.
Yeah, if 3 is the root, and I'm calculating all trees possible from 1 to 6.
1 to 6.
Yeah. Then how many trees do I have on the right?
4, 5, 6.
Yeah, which is num trees of?
6 minus 3 basically.
What? So 4, 5, 6 means 3 nodes.
Yeah.
No, yeah, so basically how you're supposed to calculate is on the right, I can only have values 4, 5, 6. So 3 values. So num trees of 3, right? Yeah, it also happens to be
Which is
6
like-
minus 3. So, yeah, we are correct. We feel like we are correct. Yeah. And it got accepted.
So yeah, my question
Yeah.
previously was, we are assuming that the given n, so you know it's starting from till n, right? So it's
Yeah.
always kind of sorted. So what if you're given an array